Hi guys, this video is about applications of systems of equations. So it's the same math we've been doing for the last couple sections, but this time as application problems. If you're in my class, when I grade these, half the credit, and it'll say on the test, set up and solve a system of equations for full credit. So I'm not looking for guess and check on this. They're pretty easy to guess and check, so that's not the point of it. But I'm looking for you to set up the system. That's about half the credit, and then the solve is going to be the second half of the credit. And generally the people who can get it set up end up solving just fine and getting all the points. So the hard part of these is getting from the words to the math. The good news is after these couple, they're all basically the same problem, just sort of with different stories going on, but how you set the equations ends up being really consistent from problem to problem. So let's look at some examples. This first one goes, two positive numbers have a difference of 29. The larger number is 5 more than 3 times the smaller. Find the two numbers. Okay, so two positive numbers have a difference of 29. So difference means subtract. It's like if it was sum, it would be add. Difference is the word for subtract. So my first equation is going to be x minus y equals 29. The larger number is, that's going to be an equals, 5 more, so there's going to be some kind of plus 5 more than 3 times the smaller, so 3 times something. The trick here, if it was a sum of two numbers, we wouldn't even have to pay attention. We could just write x equals blah blah y. But this is two positive numbers have a difference of 29. That means x has to be the larger one and y has to be the smaller one for how I had this set up. I could have written the letters backwards and made y the big one, x the small one, but big number minus small number gets you 29, because otherwise it would be a negative. So when I get here, I have to go the larger number, which I've already defined as x, so I got to stick with that, is equals 5 more than 3 times the smaller, so 3 times the smaller plus 5 more. So it kind of reads the English and the math are a little bit backwards there, but that's what we got. Find the two numbers. So now I have my system, and I can solve this. I just got to get rid of that now. To me, the easiest way to do this one is a substitution, because it's already solved for x. So I'm just going to take this right here and put it right there for that x, since this whole mess of math equals x. So that's going to give me 3y plus 5 minus y equals 29, and then I can collect some terms. And I'll bring my 5 over. So minus 5 would be 24, and divide by 2. And that makes y 12. And so that was the smaller of the two numbers, and then I can just plug that back in right here and then get the x. So x is going to equal 3 times 12 plus 5, and so that's 36 and 5, so x is 41. So our numbers are 41, 12. So this next one is a matched problem I'd have you try in class. We have one number is 2 more than 5 times another. So we'll say x is 5 times y, and then 2 more. It had been 2 less minus 2. Their sum is 50, so it's a sum, so I don't have to worry about which is the bigger or smaller. So that's just x plus y equals 50. And then again, it's kind of set up for a substitution. So I'll take this and drop it right in there for that x. And that's going to give me 5y plus 2, so that's x, plus y equals 50. 5y and y will give me 6y plus 2 equals 50. And then I can subtract my 2. 6y equals 48. Divide the 6. We got y equals 8. And once we have that, I'm going to plug right back into there. So then x is going to equal 5 times 8 plus 2, or 42. So then these next several problems all have the same basic setup, even though they read like very different problems. There's kind of a theme to how they come together. So this one goes, Gail invested money in 2 accounts. His total investment was $30,000. So if one account pays 8%, the other pays 5%, how much does he have in each account if he earned a total of $2,040 in interest in 1 year? Okay, so we're going to have some amount of money. I'm going to have X be the money at 8%. Actually, I did 5% in the notes. Let me do that. At 5%. And I'm going to have y be the money at 8%. So then, his total investment was $30,000. So that means I'm going to have the amount in X plus the amount in Y, and that's going to equal the 30 grand. And then there's some information about interest and how much his total interest was. So the interest off of the first account plus the interest off the second account is going to equal that number. And to calculate interest, I'm going to say 0.05% of the money in X plus 0.08 the money in Y equals the interest. So I'm going percent times amount, percent times amount. And remember, when you're doing math with percent, you got to move the decimal to 2 places. So that gets me my 2 equations. And for the rest of these, we're going to have this easy equation, some version of X plus Y, just kind of how the problems read. And then we'll have the second equation is going to be scaled with something. In this case, it's percents. We'll see it with coin value, we'll see ticket prices, we'll see mixture percents. But they're all going to have this kind of easy equation, and the one that's scaled, that's a little bit different. So when I solve these, I pretty much do it the same way every time, just because if I kind of do that, I kind of get into a rhythm of it, and I tend to make fewer mistakes. So for me, when I look at this, there's going to be an easy equation, and then there's another one that's not as nice. I take the smaller of the 2 numbers, I just make it negative, and then I just multiply the first equation by it. And so I'll show you why that's the one I pick when I get down below. So I'm going to do this negative 0.05 across this one. So that's going to get me negative 0.05x, same thing on the y, and then 5% of that was negative 1,500. And then I'm just going to copy this one down right below it. Okay, so then when I do my elimination, the x's drop out. Minus 5 plus 8 will give me 0.03y. And then this is going to leave 540. So the reason I picked the smaller number is then I get 2 positive numbers here. If I pick the negative number, or the bigger number, I'm going to get 2 negatives, and it just gives me 2 more minus signs to like accidentally not write down or lose as I'm doing math. So that's why I picked the smaller one. But you can pick either, it works fine. So then I'm going to divide this over. And then y is, what does that come out to? 18,000. And then since he's got 30,000 in both accounts, if 18,000 is in y, 30,000 minus 18,000, x would be 12 grand. So this one is it's not quite identical to the last one, but it's similar, so it's the problem I would have you try in class. So this one goes, Mike invested 4 times as much as 6% as he did at 5%. So I'm going to let the 5% money equal x, and I'm going to let the 6% money equal 4 times as much, so times, so 4x. And then, oops, I think that was actually, yeah, that's 6%. Sorry, I just saw a little typo in my notes there. So then the total interest he made in 1 year from both accounts was $1,160. How much did he invest? Okay, so I'm going to have, with this one, we can actually just do it a little bit sneakier. We don't even have to set up a second equation for how this read. So I'm going to go 5% of x plus 0.06 of 4x. And I could have done, x and y and then let y equal 4x, but this just seemed sort of more intuitive, and I just kind of immediately am going straight to the substitution there. So hopefully you guys followed that. And then equals the interest. The interest in the first account, interest in the second account equals total interest. And I was able to write them both in terms of one variable, so I can just pretty much solve here. So 0.5x plus, this would be 0 0.24x equals 1160. And then combining those, I'll get 0.29x, 5 cents and 24 cents. And then divide that 0.29 over. And looks like x is $4,000. And so you had 4 times as much at 6%. So then that one, so this is the 5% money, and the 6% would be 16,000. Okay, so this is the one that everyone has trouble with. A mixture of 50% solution is to be made from 70 and 40% solutions. How much of each solution be used if 120 gallons of 50% solution are needed? So it's just there's some bucket of stuff, and whatever it is, you can think alcohol or acid, or it's different things, different problems, but we're trying to make something that's 50% concentration, and we have something that's 70% concentration, something that's 40% concentration. So the idea is to try to put some of the 40 and some of the 70 and mix it up so that it comes out to a 50% solution. So if that's what we're trying to get at, our first equation, I'm just going to let x be like the, I did that one as the, in the notes, sorry, I did x as the 40%, and I did y as the 70%, and totally arbitrary which letter you assign to which number. And so I'm going to use some amount of x plus some amount of y, and that's going to make 120 gallons. So that's just how much of each one should I pour in there. And then the x is 40% concentration, so that's going to be 0.4x. So 40% of this is the stuff we're interested in. 70% of y is the same. And then we're trying to make a 50% solution. So instead of 120, now we're talking about whatever the stuff is, alcohol, acid, what have you, that's in this concentration. And so we're going to go 50% of the 120. Because say if this is alcohol, half of this is alcohol, half isn't. So only 60 gallons is what's going to equal the parts of this that are alcohol, for instance. So now that I got my two equations, I can do the thing. I'm just going to take the smaller of the two kind of messy numbers, which in this case is the 0.4. I'll just multiply that top equation. So negative 0.4x minus 0.4y equals, and then the 0.4 times 120 made negative 48. And then I'm just going to clean this side up a little bit as I bring it down. Plus 0.7, and half of 120 would be 60. And so now x's drop out, down 4, up 7, so that's going to be 0.3y equals 12, and then dividing that over, so we go 0.3, 0.3, and I get y equals 40. And since we're making 120 gallons of this, that must mean x is 120 minus 40, so that would be 80. So again, just to kind of recap the setup, we write the one for the total volume of the stuff, x plus y equals 120. And then if you look, the second equation that seems really hard is just, right, it's the first equation. It's all right there. And the only thing that happened is we put the percents in front of the equation. And so it's actually, if you just kind of remember that, it's actually not that hard to set up. This one's a ticket problem, but it's the same as the mixtures and the other one we just did, the interest problems. So for Saturday matinee, adult tickets cost $7.50, kids under 12 pay $5. 230 tickets are sold, so that's a total, for a total of that much money, so there's our other total. How many of the tickets were adults and how many were sold to kids under 12? Okay, so we have these two things that kind of feel like they're the equal side of an equation. We sold a total of 230 tickets, so I'm going to say x plus y equals 230 tickets. And then we know how much money they collected, and we know how much each ticket would have cost. So kids pay $5, so I'm going to say 5 times x Adults 750. So 750, I'll call it 7.5y equals the total money, because we're saying $5 for every kid, 750 for every adult equals the money collected. And there's our two equations. And so once again, I'm just going to take the easy equation and multiply it by the smaller of the two numbers I have. And that's going to get me to negative 5x minus 5y. And that comes out to negative 1150. And then just copy this one down. And x's drop out. This will be a 2.5y. And then this piece is 375. And I can just divide over the 2.5 on both sides. That drops out. And looks like y comes out to 150. You throw that in a calculator. And then we sold 230 tickets, so 230 minus 150, that means x is 80. And you can always, on the homework, I'll probably ask for how many kids and how many adults. Remember, you defined it right here, so the $5 went with the x, so that's kids. And the 750 was the y, so that one was your adults. Okay, so this one's a coin problem. Again, very similar to the tickets. So Walt has 29 coins with a total value of $3.45. So there's one total, there's our other total. The coins are nickels and quarters. How many of each kind of coin does he have? Okay, so I'm going to say nickels plus quarters equals a total of 29 coins. Nickels worth 5 cents. I could do this either all in decimals or all not in decimals, and I'm going to go with the not decimal version. So instead of going 0.05 here, I'm going to say 5 cents for nickels, just because I think it looks easier. I'm going to say 25 cents for quarters, and what that means is I just have to move that decimal 2 places and make it 3.45, but then I don't have to deal with decimals. I got it set up, so that's pretty much the battle. And after that, I just grab the smaller of the two numbers, make it negative, do it across my top equation. So that's going to go negative 5n minus 5q equals negative 5 times 29 is negative 145. And then just the 5n plus 25q equals 345. Nickels drop out, we're left with 20q and then 200. And then we can divide that over, and q equals 10. And so we got 10 quarters, we had a total of 29 coins, so that must mean there's 19 nickels. And this last one is basically a ticket problem, except they're stock shares instead of tickets, but it's the exact same thing. So Lydia spends $1,230 to buy stocks in two companies. If she pays $15 a share for one, $19 a share for the other, and she got a total of 70 shares, so there's one total, there's our other total. How many did she buy of each kind? So we know she bought a total of 70 shares. So we're going to have some of the one kind, some of the other kind in terms of the prices, and we know that's going to go to $70 or 70 shares. And then she had paid 15 for one kind of them, and then 19 for the other type. And so that's just like the prices of the tickets, and that equals the total amount spent. So very, very similar problem, just slightly different wording. And I'll do my exact same thing that I always do, which is take the smaller number, make it negative. Multiplying that out, I'll get negative 15x minus 15y equals negative 15 times 70 is negative 1050. And then 15x plus 19y equals 1230. And cross those out. 4y, and then doing that I get 180. And divide. And 4 goes into that, 45. So for the $19 shares, she bought 45 of those. and then take 70 minus 45, and that leaves 25 for X. And that would be the $15 shares. Cool, so that wraps up applications.